Okay, for lesson 5, we're just going to combine the skills that we learned from lessons 3 and 4. So, in lesson 3, we learned how to calculate the side. In lesson 4, we learned how to calculate the measure. And now we're just going to use whatever is required in order to complete what is asked. So, for example 1, in each case, calculate the measure of x to the nearest whole number. Well, here I'm going to be solving for an angle, and then I can see that I know my opposite and I know my adjacent. The only opposite and adjacent is going to be tan, so I'm going to say that tan of x is equal to the opposite 12.7 over the adjacent 5.2, which means that x is going to equal tan to the negative 1 of 12.7 over 5.2, or in this case, x is going to equal 68 degrees. In the second case, I know my angle, I know my adjacent, and I'm trying to solve my opposite. So I'm going to use tan again. I'm going to say that tan of 24 degrees is going to equal my opposite, which is x, over my adjacent, which is 68. Or, when I multiply both sides by 68, x is going to equal 68 multiplied by tan of 24. And in this case, x is equal to 30. For example C, I know my angle, I know my opposite, and I'm trying to solve for my hypotenuse, which means that I'm going to use sine. Sine of 69 is equal to 126 over the hypotenuse, or x. X times sine of 69 is equal to 126, which means that x is going to equal 126 over sine of 69, or in this case, x is equal to 135. For the last one, I have my angle x is what I'm solving for. I know my adjacent and I know my hypotenuse. So I'm going to state that cos of x is equal to 4.0 divided by 7.2, where x is going to equal cos to the negative 1 of 4.0 divided by 7.2. And for this one, x is going to equal 56 degrees. For example 2, a telephone pole is 11 meters high and is supported by a wire 13 meters long fixed to the top of the pole and also to the ground. Calculate to the nearest degree the angle between the wire and the ground. Well, the first thing I'm going to do is draw a little sketch of what this looks like. So I'm going to have the pole, which is going to be vertical. I have the ground, and I have my wire. This is 13 meters. This is 11 meters. And calculate to the nearest degree the angle between the wire and the ground. This is the angle that I'm trying to solve for. Now, I'm going to state that if this is my opposite and this is my hypotenuse, then sine of x is equal to 11 over 13, where x is equal to sine to the negative 1 of 11 over 13. which means that it is equal to 58 degrees. If I'm calculating the distance to the nearest 0.1 meters between the point where the wire is fixed to the ground and the foot of the pole, I'm trying to solve for what this length is, which I'm going to call y. I can use that, or do that, by using Pythag or trig. So because this is in the hypotenuse, I'm going to say that y squared is equal to 13 squared minus 11 squared. Or y squared is equal to, when I do 13 squared minus 11 squared, 48. Y is equal to the square root of 48, which is going to give me 6.9 meters. If I am using trig, I'm going to use the angle that I solve for here. And I'm going to say that in this case, if cos, I could use tan as well, but I'm going to use cos. Cos of 58 is equal to my adjacent y divided by my hypotenuse 13. Then y is going to equal 13 times cos of 58, which is equal to the nearest tenth, 6.9. Anytime it's stated to solve a right triangle, solving a right triangle means finding all of the missing side lengths and angles. You're always going to be given 3 pieces of information, and at least one of those pieces of information is going to be a side length, which means that you need to find the other angles or the other side lengths. So, in this case, if I label my sides, then I have, well, this is angle C. Let's call this the opposite one, side length C. Let's call this one side length A. Now, angle C is going to be the easiest one because all of these sides in here have to add up to 180, but if this is 90, then this angle and this angle have to add up to 90 degrees. So I'm going to say that angle C is going to be 90 minus 37 degrees, or angle C is going to equal 53 degrees. For the next one, I'm going to solve for side length A. Well, for side length A, I'm going to state that if this is going to be the opposite of the 37, this is the hypotenuse from the 37, and I'm solving, and I already said I'm solving for the opposite one, then I'm going to say that sine of 37 is going to equal side length A divided by 33, which means that A is going to equal 33 times sine of 37, and in this case that is going to give me 20 rounded to the nearest whole. For side length C, you could have called it AB as well. That's perfectly acceptable. I'm going to, for side length C, say that this is the adjacent, this is the hypotenuse, and I know my angle. Cos of 37 is equal to side length C divided by 33, which means that side length C is going to equal 33 times cos of 37. And when I do that one, it's going to give me 26. And there's my 3 missing side lengths. For example 4, it's already given me 2 of the side lengths, and I'm going to solve for my 2 acute angles, so I need to solve for angle F, I need to solve for angle D, and I need to solve for side length E. So in this case, I'm going to start by using my Pythag to solve for side length E, and I'm going to say that E squared is going to equal 5.3 squared plus 4.9 squared, which means that E squared is going to, in this case, wind up equaling 52.1. And when I take the square roots of both sides, E is going to equal the square root of 52.1, which to the nearest whole number is going to give me, the nearest tenth for the side length is going to give me 7.2. For angle F, I know my opposite and I know my adjacent. So if tan of F is equal to 5.3 over 4.9, then angle F is going to equal tan to the negative 1 of 5.3 over 4.9. Or in this case, angle F is going to be 47 degrees. And for angle D, I know my opposite and my adjacent. They're going to be the reciprocal of angle F. So tan of angle D is going to equal 4.9 over 5.3. Or angle D is going to equal tan to the negative 1 of 4.9 over 5.3. And the angle to the nearest whole number is going to wind up being 43 degrees. I always double check if I add up my 2 angles that I've solved for, make sure that they add up to exactly 90. If they don't, then that means that I made a mistake.